my channel, Notebook Maths channel. Today I am going to solve here very important problem from ordinary differential equation chapter. This is part 2. Okay, in last video I have uploaded what is order, what is degree, and what is the variable separable method. Okay, with examples I have explained you in last video. Okay, if you have any doubts, please go through that video. Okay, next video, that is part 2 from ordinary differential equations, homogeneous functions. Okay, second method. Okay, this is method 2, solving differential equations. Okay, definition is I have written already. A function f of x comma y is said to be a homogeneous function of degree n in x and y if f of kx comma ky is equal to k power n f of x comma y for every k is constant and n is a real number. Here we have the definition of homogeneous function. In this way we have to see this given function is homogeneous function or not. Okay, this for example we have the example, the function is given here f of x comma y and root x plus root y by root x minus root y. Here it is given that it is a homogeneous function of degrees 0. How? Degree means x power 1 by 2 and here y power 1 by 2, and denominator also we get 1 power x power 1 by 2 and y power 1 by 2. Total x power 1 by 2 1 by 2 get cancel and y power 1 by 2 and y power 1 by 2 get cancel. We get the 0 degree. Okay, like this the equation is said to be a homogeneous function. Okay, now we have to check the given example is homogeneous or not. Like this we have to check. Okay, working rule to solve. How to solve the differential equation whenever given homogeneous? If we have expressed in homogeneous form, okay, then what is the rule we have to apply to solve the given differential equation in exams? Okay, first of all, first point we have to observe that we have to do dy by dx equal to f of x comma y. Given problem is we have to take it as f of x comma y be the homogeneous differential equation. We have to take it as dy by dx. Okay, and then we have to express it in the form of dy by dx equal to pi of x comma y. Okay, in this we have to solve. Next, to solve this given function is first equation, and we have to put y equal to vx. Okay, we have to write in place of y we have to write vx. Okay, now differentiating we get dy by dx, this term, then dy by dx equal to v into 1 plus x into dv by dx. This one is dv by dx. Okay, like this we get the second equation, this one. Okay, this is the first equation given problem, and comparing 1 and 2 we have dy by dx, and this is also dy by dx. Okay, equating 1 and 2 we get f of x comma y equal to v plus x into dv by dx. Okay, separating the terms from variables to different terms, that is dx by x terms, dv by v terms. Okay, separating to variables, then that is separating variables is the fourth point we have to do. Next rule, that is integrating. After separating we have to do final step, that is integrating of different terms, that is x term or y term, both terms. Okay, so but here c is arbitrary constant. After integration, replace v by y by x. As we have taken here y equal to vx, we get v equal to y by x. Okay, so then we get y by x. In place of v we have to replace to get the general solution of a given homogeneous equation. To get in the form of x comma y, we have to replace v in terms of y by x. Okay, like this we have to apply the working rule to solve homogeneous functions. Okay, differential homogeneous equation from ordinary differential equation chapter. This is the video part 2. from part 1 we have easily I have explained you the order, degree, and what is differential equation, what is ordinary differential equation and first order differential equation, and what is variable separable method, first method in that video. And in this second method is there, and with a problem I am going to solve this homogeneous function given differential equation by using this rule. Okay, so if you don't have an understand first method, that is variable separable method, please go through that video. You can understand easily by following the video. Okay, now I am going to solve this question. Here what is given, solve x square y dx minus x cube plus y cube dy. He is given here in the question. We have to solve by using homogeneous function method. Okay, method 2 I am going to apply here. Here we don't have, we cannot separate these terms easily. Okay, by variable separable method we can easily separate the term by using method 1, but here we can't easily separate the terms. Okay, here x square y and x cube plus y cube, it is a very different question, so very important also for exams, for board exams also, repeated in multiple times in exam. So watch carefully, watch full video, complete video. Okay, here given we have to write it as given x square y dx equal to y dx minus x cube plus y cube dy is equal to 0. Here x square y dx minus x cube plus y cube dy is equal to 0 is given. So take this to outside, equal to, we get x square y dx equal to this minus, we get to outside, we get positive term x cube plus y cube dy. Okay, like this. Then we have dx term, here dy term. Now dy by dx, what we will get? Dy by dx x square y by x cube plus y cube. Okay, this is what dy by dx. So this is I am taking as equation 1 here. Now what is second point here? Rule, put y equal to vx here. So now putting y, we know here f of, observe that this is homogeneous or not. We have to check whether the given function is homogeneous or not. Here f of x comma y, here f of kx comma ky equal to x comma y, that is degree of numerator is x cube and denominator also x cube, y cube also there. So total 3 cancel, equal degrees. Okay, so this is homogeneous function. Now from equation 1 is homogeneous function. Okay, we have to check homogeneous function. Now second point, second we have to put, now we have to apply the rule, that is put y equal to vx. Okay, in 1. So 1 becomes what? Dy by dx equal to x square into y means v into x by x cube plus y cube means v cube x cube. Okay, so dy by dx equal to v x cube by x cube, common here 1 plus v cube we get. Okay, now v x cube cancel, v by 1 plus v cube. This is what first equation. Okay, by applying y equal to vx, we have changed y, replacing y place we get vx here. So we get dy by dx equal to v by 1 plus v cube. But after differentiating y equal to vx, here we have differentiating dy by dx, this term y equal to vx, that is differentiate this whole differentiate with respect to x, what will get? Dy by dx is equal to v into 1 plus x into dv by dx. Okay, this is also dy by dx. Okay, this is what? Second equation. I am taking it as second equation. Now comparing 1 and 2, dy by dx equal to what we will get? V plus x dy by 1 and 2. From 1 and 2, dy by dx equal to this one, and this is this one, and equating both dy by dx. Okay. Okay, now we have v and x terms in this equation. Okay, v plus x dy by dx equal to v by 1 plus v cube. Now this v I am taking to this side, x into dy by dx equal to v by 1 plus, we have to separate x terms and v terms. Okay, so this v comes to this side, becomes minus v. Okay, I am writing this to next page to understand easily. That is x into dv by dx, we get what? V by 1 plus v cube minus v we will get. Okay, here x term is there, here v term is there. So x dy by dx equal to, so LCM we get v into v into 1 v plus into minus v into v cube, v power 4 by 1 plus v cube. Okay. So now here we get cancelled. What you will get? Minus v power 4 by 1 plus v cube we get. X dy by dx is equal to minus v power 4. Now here 1 plus v cube, and this term is total v term, and only x term is there. So separate v terms to dv and x terms to dx. Okay, dv is there already. I am taking to this side. This whole term to this side, we get 1 plus v cube by, this comes to denominator, v power 4 equal to dx goes to this side and x comes to denominator. Okay, like this. Here already minus is there. I am writing here minus. So here we have separated v terms to this side and x terms to dx. Okay, now what we have to do? Next rule, that is what? After separating variables, we get what? Integrating is the last. That is, after integrating we get the general solution. Now integrating these terms, integrate. Okay, integrate now. Integration of 1 plus v cube by v power 4 into dv is equal to minus of 1 by x into dx. Okay, now here what we have? Separate this 1 by v power 4, we get v power minus 4 plus v cube minus v power 4 means v power cube minus 4, we get v power minus 1 dv. Okay, like this. Or we can write it as 1 by v. Okay, v power minus 1 I am writing as 1 by dv. 1 by dv. Okay, dv here. Here minus of 1 by x integration, we get log x d plus c. Here now we have to integrate, separate these terms. We get v power minus 4 plus 1 by minus 4 plus 1 plus log v is equal to plus log x equal to c. This log x I am taking to this side, it becomes positive. Okay, now v power minus 3 by minus 3 plus log v plus log x is equal to c. Here 1 by minus 1 by 3 v cube minus v cube. Okay, plus log v plus log x equal to c. Okay, now minus, this becomes minus 1 by 3v cube. Okay, 3v cube plus log v plus log x equal to c. Okay, this becomes log v, I am writing it as log v minus 1 by 3v cube plus log x equal to c is the last final step of this solution, that is general solution. Okay, we can write it as in the last step rule, after sixth rule, that is after integration replace v by y by x to get the general solution of homogeneous equation. So we get the general solution in the form of y by x. We have to replace y equal to y by x. Okay, we know that y equal to vx. This implies v equal to y by x. So log of y by x minus 1 by 3 into y by x whole cube plus log x equal to c is the general solution. Okay, like this we have to solve the homogeneous differential equation second method from ordinary differential equation chapter. Please watch complete video so that you can understand this part 2 method 2 of ordinary differential equation chapter, working rule, definition, and how to solve a important problem in exams. Okay, by using this homogeneous method you can solve many problems. Okay, variable separable method is the first method and second method is homogeneous method. Okay, in homogeneous we have another method that is reducible to homogeneous. In next video I will upload next method of homogeneous function, so reducing to homogeneous form. Okay, method 3. Okay, please watch complete video so that you can understand the rule to solve these functions ordinary differential equation chapter. I will continuously uploading the videos. Please go through my channel and watch complete videos so that you can understand easily each and every step. Okay, if you like this video, please like, share and subscribe my channel for more updates on maths topics. Thank you for watching. Thank you. Bye bye.